Dear students, we shall begin with Unit 7, which is Coordinate Geometry. So I presume that you already know the basics of coordinate geometry, x and y axis. Now if we consider x and y axis, the horizontal axis which is known as the x axis, whereas the vertical axis is the y axis. Now the x coordinate value, that is the distance from the vertical axis, is known as the abscissa, whereas the distance from the horizontal axis, that is the height or the vertical distance, is known as the ordinate. So this is known as the ordinate. So a point on the y-axis will have the x value 0, whereas a point on the x-axis will have the y value 0. So this is the abscissa. Now in the first part of this unit, we would need to find the distance between the 2 points. Let me consider 2 points, the coordinates being x1, y1, another point B, this is point A, another point B with coordinates x2, y2. Now if we need to find the distance between AB, so the distance AB is given by x2 minus x1, the difference between the x coordinates, x2 minus x1 the whole square, plus the difference between the y coordinates, y2 minus y1 the whole square root. Okay, so this is the formula which we need to solve the first exercise, which is exercise 7.1. Now if I would like to find the distance of a given point with respect to the origin, suppose I want to find this distance OA, then in that case the coordinates is 0, so it is just going to be x1 square plus y1 square. Now similarly, if I need to find the distance of B from the origin, since these 2 points are 0, 0, it's going to be x2 square plus y2 square the whole root, right? So in that case, if one of the coordinate values is 0, 0, then it's going to be just x square plus y square the whole root, right? So using this result, we will solve all the problems given in exercise 7.1. The first problem, we need to find the distance between the 2 points given. So there are 3 sub-problems given here. So if I need to find the distance between these 2 points, so let this coordinate be x1, y1, and the next coordinate be x2, y2. So the distance, so let these points be AB. So the distance AB is x2 minus x1, 4 minus 2 the whole square, plus y2 minus y1, 1 minus 3 the whole square, the whole root. Okay, so this is going to be 2 square. So this is minus 2 square, which is 2 square again, the whole root. So this is 8, which is nothing but 4 into 2, which is 2 root 2. So this is the distance between the 2 points A and B. So if A and B is this, so here we have AB, which is x2 minus x1, that is minus 1 plus 5 the whole square, minus of minus is plus, plus 3 minus 7 the whole square, the whole root. So this is going to be 4 square, and this is also going to be minus 4 square is 4 square itself. So we have 4 square is 16 plus 16, which is 32, right? So 32 is nothing but 4 root 2, right? 32 can be written as 16 into 2. So 16 is nothing but 4 square. So I can take 4 outside the square root, it's going to be 4 root 2. The next one, so here we have minus a the whole square plus minus b the whole square, the whole root. So this is going to be minus 2a square. Minus 2a square is nothing but 4a square. Minus 2b square is nothing but 4b square, the whole root. So I can take 4 common, and I can take it outside the square root, so it becomes 2 into root of a square plus b square. So these are the distances between A and B for the first problem. The second problem here, we need to find the distance between the points 0, 0 and 36, 15. By definition, if one of the point is the origin 0, 0, then it's just going to be square root of x square plus y square. So here the distance is x square, which is 36 square plus 15 square. So that is going to be square root of 1521. So 1521 is the square root of 39. So the distance between these two is 39 kilometers as given in the problem. Now in the third problem, we need to check if these 3 points are collinear. So let me call this as A, B and C. Now what do we mean by collinear? That means they all lie in the same straight line. So let us assume that there are 3 points A, B and C which lie on the same straight line. That means they are collinear. Now in that case, the distance AB plus distance BC should be equal to the distance AC, isn't it? So if I find the distance AB, BC and CA, when I add 2 of them, the distances between 2 points, it should be equal to the third one, right? So now let us find AB. Now AB is square root of 2 minus 1 the whole square plus 3 minus 5 the whole square. So this is 1 square plus 2 square. So this is 4 plus 1, which is root 5. So this is root 5. Next BC. So we have square root of minus 2 the whole square plus minus 11 minus 3 the whole square. So I get 4 square plus 11 plus 3 is 14 square. So I get 14 square plus 4 square, which is square root of 212. So square root of 212 is nothing but 4 into 53. So I divide it by 2, I get 4 into 53. I can write it as 2 root 53. Next, CA. So we have minus 2 minus 1 the whole square plus minus 11 minus 5 the whole square. So we have 3 square plus 16 square. So 3 square plus 16 square is 9 plus 256. So we have 265. So 265 root is nothing but root of 5 into 53. Right? Now I find that if I add 2 of them, none of them will be equal to the third one. Right? So here we conclude that A, B and C are not collinear. Right? So they are not along the same straight line. Given 3 points A, B and C, we need to check if they are the vertices of an isosceles triangle. Now if I assume that these are the vertices of an isosceles triangle, then the sides of an isosceles triangle, so there are 2 sides which would be equal. So if I have a triangle A, B and C, a triangle is considered to be isosceles if any 2 sides are the same. If AB is equal to AC, or if AB is equal to BC, or if AC is equal to BC, then it is called as an isosceles triangle. So I need to find the distance AB, BC and CA and check if any 2 sides are equal. So what is AB? So it is 6 minus 5 the whole square plus 4 minus of minus is plus 2 the whole square root. So which is 1 square plus 6 square. So we get root 1 plus 36, which is root 37. So this is what we have got. Next, BC. So we have 7 minus 6 the whole square plus minus 2 minus 4 the whole square the whole root. So 7 minus 6 is 1 Then again here we have minus 6 the whole square, which is 6 square. So this is again root 37. Next, CA. So 7 minus 5 the whole square plus minus 2. Minus of minus 2 is plus 2 the whole square, the whole root. So we get 2 square plus 0. So 2 square plus 0. So 2 square plus 0 is nothing but 2. So here we find that AB is equal to BC. So we have a triangle where AB side is equal to BC. So these two sides are equal. So therefore these three form the vertices of an isosceles triangle. So here there is a problem given where we have 4 points A, B, C, D. So it is said that one of the girls, Champa, says that these 4 form the points of a square and her friend disagrees. So let us check if these 4 form the 4 sides of a square. Now if they form the 4 sides of a square, then AB should be equal to BC, should be equal to CD, should be equal to DA. All the 4 sides should be equal if they form a square. So let us find the distances. Now AB is 6 minus 3 the whole square plus 7 minus 4 the whole square, the whole root. So which is 3 square plus 3 square, which is 9 plus 9. So we have root 18. Or we can write it as 3 root 2. So 9 into 2, take 9 outside the square root, we get 3 root 2. Next, BC. So I have 9 minus 6 is 3 square. 4 minus 7 is minus 3, again square, the whole root. So again we get 9 plus 9, which is 3 root 2. Next, CA. 6 minus 9 is again 3 square, minus 3 the whole square is 3 square, 1 minus 4 is minus 3 the whole square, so which is 3 square, the whole root. So this is again 3 root 2. Then we have, this is CD, right? The next one is DA. So we have 6 minus 3, which is 3 square, plus 1 minus 4, which is minus 3 square, 3 square, the whole root, which is 3 root 2. So I find that AB, BC, CD, DA, they are all equal. So therefore, these 4 sides form the sides of a square. So whatever Champa says is absolutely correct. So here in problem 6, we have 4 points, let me name them as A, B, C, D, and we need to identify what kind of quadrilateral it is. Let us find the distances between the 2 points. So AB is 1, minus of minus 1 is plus 1, the whole square, plus 0, minus of minus 2, this whole square. So this is 2 square plus 2 square, which is 4 plus 4, which is 8, root 8, which is nothing but 2 root 2. So AB is 2 root 2. Next, what is BC? So I have minus 1, which is 2 square. 2 minus 0 is also 2 square. So again we have 2 square plus 2 square, which is 2 root 2. Next, CD. Minus 3, minus of minus 1 is plus 1. So I get 2 square. 0 minus 2 is again 2 square. So this is 2 root 2. Next, DA. Minus 3, minus of minus 1 is plus 1. So we get 2 square plus 0 minus of minus 2 is plus 2. 2 square. So we get 2 root 2. Now all the 4 sides are equal. AB, BC, CD and DA. So definitely this is a square. Moving on with the next one, we have the 4 points, minus 3, 5, 3, 1, 0, 3, minus 1, minus 4. So let's find the distances between the 4 points, AB, CD. So what is AB? We have 3 minus of minus 3 is plus 3 the whole square, plus 1 minus 5 the whole square, square root. So which is 6 square plus 4 square, which is 36 plus 16, which is root 52. Right? So root 52 is 4 into 13. So I can write it as 2 root 13. So this is AB. Next, BC is 0 minus 3, which is 3 square, plus 3 minus 1 is 2. 2 square, the whole root. So 9 plus 4 is 13 root. So next we have CD. CD is minus 1 plus 0, which is 1 square, plus minus 4 minus 3 the whole square. So we have 1 plus 7 square is 49, which is root 50. And then DA. So we have minus 1 plus 3 the whole square, plus minus 4 minus 5 the whole square, the whole root. Right? So we get 2 square plus 9 square, the whole root, which is 4 plus 81 the whole root, which is root 85. Right? Now what do we observe? We find that all the sides AB, BC, CD and CA, they are all unequal. Right? So they do not form any specific four-sided shaped structure. Right? So all the four sides are unequal. So problem 3, we have points as 4, 5, 7, 6, 4, 3, 1, 2. So let this be A, B, C and D. So I have AB, which is 7 minus 4 is 3 square, 6 minus 5 is 1 square, so which is root 10. So AB is root 10. Next, BC, 4 minus 7 is minus 3 or 3 square, plus 3 minus 6 is again 3 square. So this is 9 plus 9 is 18, or we can write it as 9 into 2, which is 3 root 2. So this is 3 root 2. Next, CD. CD, so 1 minus 4 is 3 square, plus 2 minus 3 is 1 square, so we get root 10. Next, DA. So we have 1 minus 4, which is minus 3 or 3 square, plus 2 minus 5, which is again 3 square, which is 3 root 2. So I find that, let me draw the four sides. So we have A, B, C, D. So AB is equal to CD and BC is equal to AB. So it forms a parallelogram. Problem 7, there are 2 points, 2, minus 5 and minus 2, 9. So we need to find a point on the x-axis which is equidistant to both these points. Now let me call this point as A and let me call this point as B. Now there are 2 points A and B. So this is x-axis and this is y-axis. So first I have 2, minus 5. So this is 2 minus 5. So I have a point 2, minus 5 here. And then minus 2 and 9. Minus 2x, minus y. So minus 2 and 9. So what do we need to find? We need to find a point on the x-axis. So this is A and this is B. I need to find a point on the x-axis. Let me consider this point as P, such that A into P is equal to B into P. So AP, this distance, is equal to BP. So let the coordinates of this be x, y. Now since this is a point on the x-axis, any point on the x-axis will have the x coordinate but the y coordinate value is 0. So this will have the point x comma 0, and I need to find the value of x. So let's find AP. So where P is x comma 0. So what is AP? I have x minus 2 the whole square plus 0 minus of minus by 5 square the whole under root, and we have BP. So this is AP here. So BP is minus 2 minus x the whole square plus 9 square the whole under root. Right? So now these two are equal, that is what is given. So let me equate these two and let me take the square. So I get x minus 2 the whole square plus 5 square equals, if I take minus sign outside and square it, so we get x plus 2 the whole square plus 9 square. So taking the square, I have x square minus 4x plus 4 plus 25 equals x square plus 4x plus 4 plus 9 nines are 81. 9 into 9 is 81. 9 squares are 81. Okay. So here x square gets cancelled. So let me bring 4x to this side, so I get minus 4x minus 4x, so I get minus 8x equal to, so this is going to be 85 minus 29. So what is 85 minus 29? So we get the value as, so 85 minus 29 is 56 equals minus 8, or x is 56 by minus 8, so we get the value as minus 7. So 7 into 8 is 56. So the point is minus 7. So this value is minus 7 comma 0. So the point minus 7 comma 0 is equidistant from both the points A and B, right? Problem 8, given 2 points P and Q, where PQ is 10, the distance between P and Q is given, which is 10, we need to find the value of phi. Now what is PQ? It is 10 equals x2 minus x1, 10 minus 2, which is 8 square, and then we have y minus of minus 3, which is plus 3, so y plus 3 the whole square, the whole under root. So what we can do is we can take the square on both the sides. So this gives us 100 equals 8 square, which is 64, plus I have the square of this, y square plus 6y plus 3 square is 9. So now 64 plus 9 is 73. So I have 100 minus 73 equals y square plus 6y. So this gives me a value 27 equals, can I take y common? Yes, y into y plus 6. So what could be the value of y? Now we know that 27 can be written as 9 into 3. 9 3s are 27. So if y equals 3, then I would get the first case where 3 and I have 6 plus 3 is 9. So 9 into 3 gives me 27. Okay. But what happens if y is equal to minus 9? So if y is equal to minus 9, even then 27 is minus 9. This is minus 9 plus 6, which gives me minus 3. Minus 9 minus 3 gives me 27. So we have two answers. So y can either be 3 and y can be minus 9. In both the cases, I get the value 27 here. So the point Q can either be 10 comma 3 or can be 10 comma minus 9, where the distance would be 10. PQ would be 10 in both the cases. So in the next question, the point Q is equidistant from P and R. So we need to find the value of x. So it means there is a point P and there is a point R and we have a point Q. So Q is equidistant, so QP equals QR. So let us find QP and QR. So we have PQ, which is 5 minus 0, which is 5 square, plus minus 3 minus 1, 4 square, the whole root. So I have 25 plus 16, which is root 41. So PQ is root 41. Next I need to find RQ. So x minus 0, which is x square, plus 6 minus 1 is 5 square, the whole root. So I have x square plus 25, the whole root. So given in the problem, these two distances are equal, right? So PQ, this distance is equal to QR, so let me equate both of them. So we have 41 equals x square plus 25 if I take the square on both the sides. So bringing this 25 here, I get x square equals 41 minus 25, which is 60, or x is equal to plus minus 4. Okay, so x can be either 4 or x can either be minus 4. In both the cases, we find that the answer is valid. So we need to now we need to find the value PR. So since I have x equal to 4 or minus 4, let me consider the first case if x is 4. So here x is 4, so I need to find PR. So we have 4 minus 5, which is minus 1 the whole square, plus 6 minus of minus 3, which is 9 square, the whole root, which is root 82. This is 81 plus 1, which is root 82. Now if x is equal to minus 4, then what about PR? So if this is minus 4, I have minus 4 minus 5 the whole square, which is 9 square, plus 6 plus 3 the whole square, 9 square. So we get 9 square is 81 plus 81, which is 2 into 81, which can be written as 9 root 2. Right? So if x is 4, then this distance PR is root 82. If x is minus 4, then this distance is going to be 9 root 2. The last problem in this exercise, it's been given that the point xy is equidistant from A and B. So we need to find the relation between x and y. So I have a point O. So given AO is equal to BO. So the distance between the point O and A is equal to the distance between the point O and B. So let us find the distance here. So we have 3 minus x the whole square plus 6 minus y the whole square, the whole root of course, must be equal to minus 3 minus x the whole square plus 4 minus y the whole square, the whole root. So if I take square on both the sides, I get this equation. So now taking the square, we have x square minus 6x plus 9 plus y square minus 12y plus 36. So this is nothing but plus 3 plus x the whole square, because I have a minus sign common here. So this will give me x square plus 6x plus 9 plus y square minus 8y plus 4 square is 16. So what are the terms which can be cancelled? So we can definitely cancel x square, we can cancel y square. So I have 6 minus 6x and plus 6x. So bringing this to LHS, I get minus 12x. We have minus 12y and minus 8y. If I bring this to LHS, I get minus 12 minus 12 plus 8. So which is going to be minus 4y that is 12 plus 8. Minus 12 plus 8 is minus 4. Here on this side we have 36 plus 9, which is going to give me 45 PLHs. On this side we have 16 plus 9, which is going to give me 25. So we have 45 minus 25. So 45 minus 25, which is going to give me 20, plus 20 equal to 0. Right? So let me divide the entire equation by minus 4. So if I do that, I get 12 by 4 is 3x plus y minus 20 by minus 4 is minus 5 equal to 0. So we have a point xy which is equidistant from the 2 points A and B. So we have got an equation with respect to the points x and y. So in this session we have covered all the problems given in exercise 7.1. I hope you have found the video informative. Please do like, share and subscribe. And in the coming videos we will solve all the problems given in the exercise 7.2 and so on, and also explain the concepts required to solve those problems.